Hello, today's lesson will be divided up into 3 short videos and 3 mini lessons. And that's because now that we know what an integral is and antiderivative is, it's not that hard to do a definite integral and look at the fundamental theorems of calculus. So I know we're doing 3 mini lessons in one, but it won't be that bad. And then the first video and first mini lesson of 3 is quite short. So we're going to look at the definite integral. I did introduce this last lesson. We talked about integrals. There's definite and indefinite. We should be really good at doing indefinite integrals now. Indefinite is when you're not given the limits of integration. So indefinite is just finding the most general antiderivative. So definite just means you're given the limits of integration. So to solve for that, step 1 is still the same as our last 2 lessons. You still need to start by finding the antiderivative, using the antiderivative rules, the integral rules that we have in our textbook and on that sheet. And then here's the new step. Once you do that, then you need to substitute in those values and you take the upper limit minus the lower limit. And that's it. So step 2 is the only part that's different than last time. So this will be a really short, quick lesson. We're just going to do 2 examples together before we go into the fundamental theorems of calculus. So for our first example, we're going to integrate x dx and our limits are from 1 to 2. So we start off the same way as we did last time using our antiderivative rules. So when we integrate x dx, we get x squared over 2. Now we could put the plus c. I did have those videos that I wanted you to watch ahead of time where it was explained why you don't have to put the plus c. You could, but when you subtract it, it cancels each other out. So there's no need to put the c. It's technically there, but it kind of works itself out. So we can just drop that step. So x squared x squared over 2. Now if this was an indefinite, you put plus c and you're done. But for definite, we now have to account for those limits of integration. So we know the limits of integration go from 1 to 2. So here's the next part. You just substitute in the top limit minus the bottom one. So first you replace your function, or you replace your x values with 2. And then from that you subtract your lower limit of integration, replace your x's with 1. So that's not bad. And again, the math after that is pretty easy. So I have too many brackets around here. Oh, communication error. The brackets just go around the numerator just to be clear there. Okay, so that would be 4 over 2 minus 1/2. When you solve that, our answer should be 3 over 2. So that's what you do for definite integrals, still the same rules, but then you just substitute in your limits of integration and subtract the top minus the bottom. Okay, so 3 over 2. Not bad at all. So we're just going to do one more example because I think it's pretty straightforward. So our function f4 plus 3x squared dx, and we are given the limits of integration from 0 to 1, so that means it's definite because we're given the limits. So step number 1, we're going to find the antiderivative using our rules. So that would be, we have 4x plus 3x cubed over 3. You could put the plus c, but it'll cancel out when we subtract, so we're just not going to. And then we apply the limits of integration. It's going from 0 to 1. We can simplify that a little bit just to make it a little bit easier. 3 divided by 3 is just 1. So then we just now subtract with our upper limit minus our lower limit. So first we replace all the x's here with 1. Make sure I have my brackets correctly. And then from that we subtract 1, we replace all our x's with the lower limit, which is 0. Okay, now this isn't calculus at all. This is really easy. 4 times 1 is 4, 1 cubed is 1, so 4 plus 1 is 5, 0, 0, so the answer there is 5. Okay, so a nice quick lesson because we spent 2 lessons already on just antiderivatives and the indefinite integral, so it's really easy just now to go to the definite integral. Okay, good luck with this part, and then we're going to have 2 more videos on the fundamental theorem of calculus part 1 and fundamental theorem of calculus part 2.